Hello everyone, welcome back to my channel. Today let's go over a medium question that I finally solved on my own after a lot of trial and error. So again, I'm really happy about this. It took me many memory limit exceeded and wrong answers, but I kind of played around with the test cases a little bit and I was able to solve it on my own. So again, really happy about that. So let me show you my own solution. Basically, you're given an integer n and you want to get all the intervals that are not covered. So it's easier to show you with the picture because basically you start from 0 and then 1 less than this is 2, 1 more than this is 6, 1 less than this is 6, 1 more than this is 9, right? And each one has to have at least two, each sublist of the grid has to have at least 2 elements inside of it. So let's go ahead and take care of some edge cases. You notice here that you can actually merge these two if you sort them. So this is just 0 and 4 because 2 and 3 are between 0 and 4. So let's go ahead and sort each sublist by its starting element. So do like a merge intervals, ranges.sort. This just makes it easier to see which areas are covered and not. So if this is less than or equal to this, plus 1 actually, because if this is 6, then it's still continuously covered, right? We're covering up to 5, and then if this was 6, then we're still covering up to that. So what we can do is get ranges of 0. This is always going to be the smallest in the entire matrix, right? Because we sorted it by start times, and then we always know this element is less than this, less than or equal to this at the very least. And so now what we can do is go over ranges. And we're going to go from index 1 because we want to merge. So this is going to be the final merged. Let's call it merged. And we're going to say if ranges of I of 0, which we're starting at 1, so we're starting at 2, is less than or equal to ranges of I or new of -1 or merged of -1, -1 plus 1, then that means that merged is going to start as 0 and 3. This is less than or equal to 3 plus 1, so then we're going to take the maximum of this and update this to become 4, right? Because we just want to merge these together so we don't have two separate lists. So merged of -1, 1 is the maximum of itself. And so now we're comparing these and these because we know this and this is overlapped because this has to be less than this. This has to be bigger than this bigger than this. So ranges of I of 1. And otherwise, if there's no overlap, then we have to append the current ranges of I sublist, right? So if we print merged, you'll see. Cool. Now we have 0, 4. Beautiful. Now we can go from n, well, 0 is covered. So the next from 0 is 5. That's the smallest number that's not covered. And then 6, you always have to do n minus 1 has to be included. So if it's not covered, so 9 here, n minus 1, 10 minus 1 is 9. 3 minus 2 is covered, so we don't do anything. This is just an empty list. Okay, cool. So now let's get rid of this print statement. And what we're going to do is actually get the smallest and the largest, right? The smallest and the largest is going to be 0 and n minus 1, as I mentioned. 0 and 9, 0 to n minus 1, 0 to 2, 0 to up to 6. And then we're going to have a intermediate list here, because what we want to do is actually just say, so we want to say the edges, the boundaries. Boundary, let's just call it B, and we're going to add smallest and largest to it. And now if whatever the smallest one is, so ranges if smallest or ranges of, let's see how this is, less than or equal to smallest within the range. So again, this did take quite a bit of trial and error, but if if we're in the range, okay, you know what? Let's just actually do this for now and not worry about these edge cases that we'll take care of later. So now that we have our merged, what we want to do is have a sorted list and go over merged. We're going to add m of 0 minus 1. So the low and the high is going to be m of 0 minus 1, m of 1 plus 1, right? So 4 and 6. So if, okay, so sl.add low, sl.add high, let's print sl. So now we have this, except this is like half done because basically we don't have to include anything that is equal to n. So if high is less than n, then we do this. If low is bigger than or equal to 0, then we add low, right? Because -1 doesn't count, so this gives you nothing. This gives you 2669, and this gives you 5, which we also need 6. So we're also just going to add n minus 1. So sorted list is like this, and then we also have to add 0 because we got the edges. So 0, 2, 6, 6, 9, 9. So sl.add n minus 1, which we already did. So if we print this again, and then we also have to add 0. Cool. So 0, 2, you can just do this, 6, 6, and 9, 9. This one is just 0, 2. It's not. So now, because this is already covered, right? So we have to sort out anything that's already covered. So for S and, let's see. That's why we're doing it here. So if low is bigger than or equal to 0 and low is, let's try to see how we can remove the covered intervals now. So for example, 0 is covered, right? So okay, so SL, if low is bigger than or equal to 0, so if low is bigger than or equal to 0, then do we do this in the ranges or the smallest and the largest? So 0 to 4, notice we don't want that here. Smallest to largest here is 3 and 8. We don't want those. 0 and 2, we don't want those. So maybe smallest, largest, so anything between the smallest and the largest. So for and low is not equal to smallest. Is that what it is? Maybe we just do this again. For S and SL, if S is equal to smallest or S is equal to largest, then SL.remove S. Print SL again. Nope. Wait, no. The smallest is supposed to be ranges of 0 and 0. And the largest is supposed to be ranges of -1, -1. Okay, cool. No, we still don't want 2 though. If S is equal to largest, let's print SL. Why are we still... This is not supposed to be 2. Yep. That's what it is. 0 and 2 and then 2, right? So, okay. Let's just do SL.remove smallest, SL.remove largest. Let's print SL. Discard maybe? Okay, cool. There we go. Cool. Now we can just grab the pairs, right? 2 at a time. That's it. So for I in range 1 length of SL, say answer dot-append SL I minus 1 SL of I with the step size of 2. So we go forward by 0 and then 6 and then 9 instead of 0 to 2, and then return answer, right? So, oh, out of range. Okay. So now if ranges exists, then we do this. Otherwise, if the input is empty, then you just return, you notice 0 up to n minus 1, right? So return there equals to 0 n minus 1, and then return a list answer, right? Just got to play around with the test cases and observe. And there you go. Passes all test cases. Again, not the most efficient solution, but I did come up with this on my own, so I'm pretty happy about this. And that's it for this video. Thank you for watching, and stay tuned for more.